Hey there, peeps. It's time to introduce you to our problem-solving method and a checklist to go along with it. There are 11 steps. It's like Spinal Tap for those who might be familiar with the movie. I know that a few of the musicians are. And one of the lines is, these go to 11, so does our checklist. I'll bet when you signed up for this course, you had no idea. But each of these steps is going to help us organize our thoughts and interpretations of physics in a way that's organized for others to be able to read and use in such a way where it's also a communication system. So not only does it help you structure what's happening and also the mathematics and everything else involved to model the system, but it's going to help us communicate each level so that when you're stuck, it's easier for someone to step in and go, oh, it's right here, I get it. So let's start with number one. The first thing you do is read the problem. It sounds obvious, but when you read the problem, you look for certain keywords. For example, you might come across starts from rest. That automatically should enable your thoughts to perceive a velocity which starts at 0 meters per second. Or maybe when you read it, one of the keywords is comes to a stop, which means that your final velocity, your v, is going to be 0 meters per second. So these things are clues without actually saying 0 meters per second literally that we can interpret from the text that allows us to structure the problem properly. We want to visualize what's happening. We want to create drawings and diagrams of the situation. Physics is improved when we can model that with pictures, with ways that can actually model the system from different angles. Something that certainly supports the situation is going to be aided graphically like that. And especially later when we deal with something called forces that have 2 dimensions and angles, and that type of thing will be enhanced when we can visualize and also express that visualization through a diagram and drawing to help solve the problem. Even now with our motion problems, it's important that we do this. We need to identify variables at play. The first variable I call the question variable. It's, okay, what are we trying to solve? What is the problem asking? What are we finding? That's the most important one to start with because that's going to structure our branching point, where we take off from to solve the situation. Then the rest of them are supporting variables, the ones that are known and given pieces of information that help determine our final answer towards the initial question, okay? We need to list values and the units associated with it. Of course, we're using MKS, meters, kilograms, seconds, as our standard. And with the proper units means that we need to sometimes convert to these MKS units. For example, kilometers per hour, not MKS. We need to convert that to meters per second for a velocity. We need to resolve vectors when we're dealing with 2-dimensional problems. Sometime later, particularly when we incorporate gravity, we're going to be working in 2 dimensions. And so we may need to split up the problem into what are called vertical and horizontal components. And so we would expressly do that at this step over here. It's important to, in number 6, select equations. Which equations are applicable from the physics that we know? These equations model the situation, but we need to be able to select the proper ones with the variables that we've identified in order to process the results further and to get the correct answer. Then, of course, once we have those equations, we solve for the variable using symbolic algebra. I'm going to be an incredible stickler about this step over here. You must solve symbolically. You must solve for the letter before applying any numbers. One case in point is I may ask you to repeat with a different set of parameters. One of the activities that we did where we modeled with the computer in Logger Pro, we had t, time, and we were able to generate a list of 100 seconds at 1-second intervals and see what the difference was. Now that came about because of the symbolic algebra already being solved. So when we solve it, we can model it as a formula in a computer program like Logger Pro and take advantage of that. Of course, the procedure we use to even solve it in the first place, the algebra, is called SADMAP. So that's the one you would use to isolate the variable. which we learned much earlier on. We need to, finally at this point, once you've isolated your variable, substitute your numerical values in. And then you're going to evaluate the expression using PEMDAS. Okay, so once the numbers are substituted, there's a procedure for evaluating the expression to come up with the proper arithmetic result, that answer. And speaking of results, we need to present them properly. Presentation of results has to be neat, has to include units, and has to be boxed in. Each answer has to be boxed in order to find it. It has to be easy for someone to be able to see your process, but also the final result. And that includes me, not only because I'm a teacher, but you guys in communicating with each other will find that when you're describing a situation to your peers, they're going to have a much easier time helping you too. And then lastly, we're going to include, as step 11, the discussion statement, which includes sentences about the relevant physics that's involved. How does it play in with the context of the problem? So as something is elaborated, it gives us a better understanding of what's happening physically. I don't want the number to explain it. Sometimes that's really not sufficient. I need to know that you can describe the physics properly and also relate that to the context of the original question. And that's the process. So what I'm going to do next is actually solve a problem for you, actually one that you have seen in your pre-assessment. So we're going to do that following each of these 11 steps so that you can see what it's like. Now, does it take a little bit longer to go through this? Yes. I'd rather do less problems, do them thoroughly and well, than do lots of problems shoddily, quickly, without the ability to communicate them. So I'm aware that it takes longer to do this, but it's well worth it in the end. So this is the process. You've come to the right place for getting it all down, prepare you for college physics. Right on.